Guys, welcome back to my YouTube channel. We have this typical question here. We're still under mathematics and 6. We're still under partial derivative. We have this typical question here. We have given w is equals to f of x, y, z. It's up to you which one notation you prefer. Is equal to x e raised to the power of x y plus y e raised to the power of x z. So determine number one, we should determine that derivative of w x dot. Okay, let us check. By the way, there, this is what we have there. So we have there number one. I can write that equation. I can call it w. It's up to you whether you want to call that. Is one and the same thing. Say x e x y plus y e x z. So supposed to find the partial derivative of this respective to x. Then here you check, we have x, so here we're supposed to apply the product rule. I will differentiate the first derivative of x is what will be 1. Then then I differentiate this. Remember, you will have to differentiate the exponents. You multiply by the derivative of the exponents, whereby our constant there is what will be y. We multiply this by y. This will be exy. Remember, this is an exponential function. We know how to differentiate that. All right, this is a product. Obviously, you say plus again. Oh, sorry, this is a product rule, guys. Sorry, that is a product rule. This one you will write it is axy like that. Then you say plus. We started differentiating this we don't differentiate. I come to this side, I don't differentiate x. Then I differentiate the second one. If I differentiate the second one, this will be x, will be x multiply by what there, by y. All right, multiply by y e x y. Right, with that we have applied the product rule here. Then we come to this guy. There we have y simply just a constant. Then here we multiply, here it's z, we multiply this by z. We know how to factor y, how to differentiate an exponents, right? This is what we know. So this is what we'll have here. All right, this is what we have for the first part. All right, so number two, supposed to find w, or partial derivative of w. Y was still there, so is wy. So okay, y is only here. X will take x as a constant. We'll just write that x, then we'll multiply by x again. Then we'll have e raised to the power of y like that. Remember, this is how we factor. That is how we differentiate the exponential. Then we come here, we have plus. Here we have y will simply equals to 1. Remember, it's only 1 there. Y will be 1. The derivative of y, this is simply just the same as a constant to these ones there, that is z. So all right, so here we'll have multiply these two, will be x squared exy plus exz. All right, so let's check number 3. We have there number 3. We'll have a derivative of w into what, z. So we're still here. we don't have z here. Nothing consists of z is the same as a constant. This will simply equals to 0 plus y will take y as a constant, will simply equals to y. Then here we know this is an exponential function. You multiply by the derivative of the exponent, whereby x is our constant, it's the same as constant. You multiply by x, then would be e x z like this. Then this will simply equals to y, yes, x e y. This will simply equals to our y x e x z like that. So this is what we have so far. All right. Those are typical question. So we have this typical question again. This typical question says there, example 1.7 says if f of x and y z is equal to square root of x squared plus y squared plus z squared, show that x multiplied by the partial derivative of f in respective to x plus y multiplied by the partial derivative of x in respective to y plus z multiplied by the partial derivative of f in respective to z must be equal to this. So we're supposed to show that if we take the derivative, we multiply the partial derivative of this must give us that. Okay, so we're supposed to find the derivative of this guy that we are given if we're given that. So we have this derivative there, the partial derivative. We have those derivative, we'll multiply them by x. Okay, it's fine. We come here, I can call this f, no problem, because it's f, because here they just denoted f. I can say f there like this. I can say f, can call this, and then rewrite the equation here with x squared plus y squared plus z squared, right? So can rewrite this. This is the same as again x squared plus y squared plus z squared into 1 over 2. So we have this now. I can take the first partial derivative, the one there, the partial derivative of f like this in respective to partial derivative of x. Then we know I apply the power rule. I drop the exponents, multiply by the exponent there would be 1 over 2 like this. Then we know what we're supposed to do. We'll apply the chain rule. We know what's supposed to do. Okay, we subtract 1 there on the exponent, also will be negative 1 over 2, multiply, use the chain rule, but now in respective to what, x. So these guys, these two will be multiplied by, we drop the exponents, is x squared will be 2x. These guys will simply just plus 0 because in respective to that. All right, this is the same as what? Now 1 over that will have, this is the same as again 1 over, this is the same as 1 over, oh sorry about that, this is the same as 1 over, remember this, you can take this again to the bottom, will be same as square root again of x. Remember 1 over that will be same as square root squared plus y squared again plus z squared. We still have these two here, we'll have that 2, then multiply by what, by these 2 here. Can simply write these 2 here. Remember these 2 can come here, can write that 2 there because you're multiplying, isn't it? This is 0, is nothing. So if I multiply that, but now these 2 and these 2 must cancel nicely. So 1 multiplied by x will simply x all over the square root, all over the square root. Here we have all over the square root of what we have now. Here we still have x squared plus y squared plus z squared. All right, this is what we have, guys. This is it was that part. Anyway, if we continue, this will be the I want to, since guys we have this, if I take again the derivative of f in respective to y, we still gonna get the same thing, but now we'll change. What will change here, if we take again the derivative of f in respective to y, here on the bottom we'll have y. Okay, let us take 1 so that you'll see this is just a repeating process. Now let us take the derivative of, you have to, let's see. Now I want us to take the derivative of, or the partial derivative of f and respective to y. You'll see there, here was our original equation. Here supposed to drop the exponents, isn't it? We're dropping the exponents. We'll have this, we'll multiply here by what, let me just show you. Here we multiply here, the others, this will become 0 and 0, so this will be the same thing, will be here 1 over 2 into x squared plus y squared plus z squared into minus 1 over 2, multiply, remember this will be 0 0, this will be what, multiplied by 2y. So it's repeating the same process, we're repeating the same process, but what will change there is only the variable. This will be simply what is the same as 1 over 2 square root x squared plus y squared plus z squared, isn't it, multiplied by these 2, then multiplied by 2y. So this and this will cancel, we'll be left with y over, you see what is changing, it's only the numerator, but this is the one and the same thing, guys. This will have x squared plus y squared plus z squared. So you see the first one was x, so similarly you see here it was x over square root of x squared, so here it's y. Similar, guys, therefore even the one of z, what I'm doing there, similar, even the one of z, guys, similar, even this one of z, will simply equals here to z over the square root. As you can see, the pattern there is continuing like that, plus z will have this. So yeah, so this is what we have. What do they say? They said they want us to prove this now. To prove this, what you see, this you multiply by x, that one you multiply by y, that you're supposed to have to show that is equals to this. All right, let me write this equation that we're supposed to prove like that. Okay, plus y like this plus z, then we have z. So this is the typical thing that we want to do. Let me just can copy this, it's fine, then I will write it here on the bottom, it's fine. Let me write it this here on the bottom, our bottom page. Oh yeah, on our bottom page. this is what we're supposed to prove. By the way, we're supposed to use this. This is what we're supposed to have there. Okay, then they said this supposed, if we prove this supposed to be equals to what, to f of x y z, like that. Let's check there. Yeah, y like that supposed to be equal to x y z. So as you can see, guys, you've seen the process. This is what we'll have, x over the square root, like until that. We know that here we'll have x multiplied. Now we know this will be what, x over, we've seen that the square root of x squared plus y squared plus z squared, plus we come here y multiply into y over, because this, remember, we've calculated this guy, we know that will be equals again to the square root of x squared plus y squared plus z squared. Similarly, plus z will be equal to z on the top, then square root of x squared plus y squared plus z squared. This is what we have. So my maths here, if I check, this and this will cancel. Yes, according to my math, they are left with that must cancel, because the one they are multiplying, are left with 1 over the the square root of x squared plus y squared plus z squared. Similarly, this and this will cancel, that and that. This is like that. All right. Similarly, so we have our, the common denominator are the same. Oh guys, we are multiplying there. So we're not dividing, guys. I almost did the nonsense. I saw it, by the way. I did not. Sorry guys, we are multiplying, by the way. We are not dividing. If I multiply that, those would cannot cancel. You, what a lame maths. Sorry about this silly mistake. This will be x squared, obviously. All over x squared. Why seems like I'm doing such a stupid mistake? Plus this will multiply, will have y squared. That was a stupid mistake. Right, plus multiply this will be z squared over x squared plus y squared plus z squared. Sorry about that. Very stupid mistake, by the way. So yeah, we know the maths, they are the same. If this is a fraction, you take one, you add the numerator, isn't it? We take the one denominator, then we'll add the numerators, denominators here, x squared plus y squared plus z squared. We want to prove, guys, this supposed to be, want to have this x y z, said we should prove this. All right, let's check. Let's come back to our stuff, guys, here. But we know that this is equal to this. All right, where I see this, I will replace with that. Now I come, because this is equal to that, and then we have the square root. Remember, this is equal to this, and then we have the square root of that. I'll replace with this. All right, in that space. So I come, I replace that here. As you can see, if you may check, if I can, here at the top we have x squared plus y squared plus z squared. The square root, here we have the square root. The square root is the same as that we are given there on the statement. It's the same as that. I will do like this. But what about this, guys? What this on the top? How can we find this squared like this? So you'll manipulate, because on the top we don't know that. But what if we can square? All right, we have squared. How can, okay, this will be pretty nice. I can do like this here. Take the square, can square both sides. If I square both sides, this and this will cancel. The square root and that will cancel. So we'll be left with f of x, y, z there, isn't it? Y, z there, raised to the power of what? We squared that, raised to the power of 2. This will simply equals to x squared plus y squared plus z squared. So I will replace that. I will square this. Remember, this will be same as this. So I come here. Let's see now. Okay. So since we have seen that, then we can do what we know now. This is the same as f of x, y, z, but remember we've squared. We made this to become two of them. We squared this, we've squared all over f of x, y, z. So this is the same as like there are two. Remember those, if you distribute, will come here. This is the same as f squared x, y, z, like this, divide by f x, y, z. So we can prove this is the same, the laws of exponents. We take one of the exponents there. This will be left with what? Remember, we can write what is in the top, or we can write this, because they are the same. You can rewrite this. Squared is the same as, remember, it's the same as x, y, z, multiply. Remember, the same as like that. Divide by what we have here. If you want, you can view it in this manner. All right. So the one will cancel, will be left with what there? They are left with now f of x, y, z. This is what we're supposed to prove, isn't it? So that is how we have it. So we've proven this now, guys. So this is what we have. So we got what they've talked here. We have that now. So this is how you go about the handling this typical question. So nevertheless, guys, thank you, by the way, for watching. Thank you for watching. All right, and please guys, do not forget to subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video. Feel free to like and to comment, and feel free to share this to your fellow classmates. All the best.